The reconnaissance photograph trembled in Lieutenant Commander Saburo Sakai's hands as he studied the impossible sight captured by a daring photo mission over California in August 1945. Row after row of pristine American fighter aircraft stretched across multiple airfields, each one representing industrial capacity that Japan had never possessed. The image showed over 2,000 P-51 Mustangs at a single facility, more fighters than the entire Japanese Navy had operational at the height of their power. Sakai was Japan's most decorated fighter ace, a pilot who had engaged American aircraft across every theater of the Pacific War. His professional eye could assess enemy capabilities with precision born from 3,000 hours of combat flying. But the intelligence photographs spread before him defied every assumption he held about industrial possibility and strategic resource allocation. The reports from multiple sources painted an unthinkable picture. American airfields contained over 20,000 ready-to-fly fighter aircraft, with thousands more in various stages of completion or storage. Production lines were delivering new fighters at rates that exceeded Japan's total aircraft manufacturing across all types. The mathematical impossibility was staggering. America was producing more fighters in a month than Japan had built during the entire war. For a nation that had scraped together 5,000 operational fighters at its peak strength, the sight of endless American aircraft represented not just industrial superiority, but a fundamental redefinition of what modern warfare could achieve through systematic abundance rather than tactical excellence. If you want to discover more incredible stories of how American industrial supremacy overwhelmed even the most experienced enemy forces, make sure to subscribe to our channel and hit that notification bell. Lieutenant Commander Saburo Sakai had claimed 64 aerial victories against Allied aircraft, making him one of Japan's most successful fighter pilots and a living legend among naval aviation forces. His combat experience extended from the opening strikes at Pearl Harbor through the desperate defensive battles over the Japanese home islands, providing him with unmatched knowledge of American aircraft capabilities and tactical evolution throughout the Pacific War. The intelligence briefing at Atsugi Naval Air Base in August 1945 presented Sakai with reconnaissance photographs that challenged everything he understood about enemy production capabilities. American airfields photographed by high-altitude reconnaissance missions revealed fighter aircraft concentrations that seemed to violate basic principles of resource allocation and strategic planning that Japanese military doctrine had always emphasized. North American Aviation's Kansas City plant showed over 1,800 completed P-51 Mustangs parked in systematic rows, awaiting delivery to operational units that already possessed more fighters than they could effectively deploy. The casual abundance suggested American production capacity that treated individual aircraft as routine inventory rather than precious strategic assets, requiring careful conservation and tactical deployment. Republic Aviation's Long Island facility contained similar concentrations of P-47 Thunderbolts, while Lockheed's Burbank plant displayed thousands of P-38 Lightnings in various stages of completion and storage. The combined fighter production, visible in a single reconnaissance mission, exceeded Japan's total aircraft manufacturing capabilities across all types during 4 years of maximum wartime mobilization. Technical analysis of photographed aircraft revealed American manufacturing quality that maintained peacetime precision standards despite wartime production urgency. Systematic organization, standardized procedures, and quality control measures achieved consistency across thousands of units that Japanese craftsmanship traditions had only accomplished through individual attention to single aircraft construction. The psychological impact on experienced pilots like Sakai reflected growing comprehension that Japanese tactical excellence had been matched against industrial capacity that rendered individual skill mathematically irrelevant. American abundance enabled replacement of combat losses faster than Japanese forces could inflict them, transforming aerial warfare from tactical art to statistical inevitability. Personal combat experience provided Sakai with intimate knowledge of American fighter performance that confirmed the devastating implications of massive production quantities. P-51 Mustangs possessed range, speed, and maneuverability that equaled or exceeded Japanese aircraft specifications while being produced in numbers that Japanese industry couldn't approach through any conceivable resource allocation or manufacturing innovation. Intelligence reports indicated American fighter production rates of 2,500 units monthly across all manufacturers, compared to Japanese peak production of 1,400 aircraft monthly, including all types from trainers to heavy bombers. The production ratio of nearly 2-to-1 in fighters alone represented systematic advantages that tactical competence couldn't overcome through traditional methods. Strategic implications extended beyond current military operations to encompass post-war global relationships that would be determined by industrial capabilities rather than military victories achieved through individual courage or tactical innovation. American fighter reserves represented technological advantages that would influence international aviation development for decades following the conflict's conclusion. The workforce development that enabled such production included systematic training programs that produced technically competent workers within months rather than years, contradicting Japanese assumptions about the time required to achieve manufacturing excellence. Democratic industrial organization had proven more efficient than traditional apprenticeship methods for large-scale technical achievement. As August progressed toward Japan's inevitable surrender, Sakai began to understand that his aerial combat experience had been futile resistance against mathematical certainty rather than strategic competition between equivalent industrial powers. The North American Aviation Facility in Inglewood, California, operated with mechanical precision that produced P-51 Mustang fighters at rates that Japanese observers found incomprehensible. Assembly lines completed 25 aircraft daily, while maintaining quality standards that exceeded Japanese peacetime manufacturing, despite production volumes that Japanese industry had never attempted under any circumstances. Engineer Hiroshi Tanaka, assigned to analyze captured American production documentation, studied manufacturing procedures that revealed systematic approaches to fighter construction that Japanese tradition had never developed. Standardized components, interchangeable parts, and automated assembly processes achieved consistency across thousands of units while enabling rapid production expansion that traditional craftsmanship methods couldn't accomplish. The workforce diversity at American fighter plants contradicted Japanese assumptions about technical competence and social organization. Women comprised 40% of assembly workers, performing complex operations with precision that Japanese military tradition had reserved for male technicians. African American workers operated sophisticated machinery, while immigrant employees contributed specialized skills that enhanced rather than compromised manufacturing effectiveness. Raw material allocation supporting American fighter production indicated resource availability that Japanese planners found difficult to comprehend. High-grade aluminum flowed continuously from domestic smelters, while specialized alloys arrived from suppliers operating without material shortages that had constrained Japanese manufacturing since 1943. American industry faced organizational challenges rather than resource limitations. Innovation acceleration continued throughout mass production rather than being sacrificed for quantity targets, contradicting Japanese beliefs about the incompatibility of creativity and systematic manufacturing. Engineering improvements enhanced fighter performance while reducing production complexity through competitive methods that centralized planning had never achieved, despite ideological motivation or administrative efficiency. Quality control procedures exceeded Japanese military specifications while processing millions of components through statistical sampling methods that ensured reliable performance across entire production batches. American standardization achieved precision through systematic testing rather than individual inspection, enabling mass production without compromising functional requirements that Japanese craftsmanship had emphasized. Economic efficiency of American fighter production challenged Japanese understanding of resource allocation in competitive technological development. Unit costs decreased as production volumes increased, demonstrating systematic advantages in manufacturing technology that competitive markets had encouraged through innovation rather than administrative direction or ideological compliance. Supply chain coordination operated across continental distances without transportation disruptions that plagued Japanese manufacturing. Components manufactured in multiple states arrived on schedule for final assembly, while finished aircraft moved efficiently to operational bases using railroad and trucking networks that maintained delivery schedules regardless of weather conditions or competing military demands. Training programs produced qualified workers faster than Japanese educational systems could achieve through traditional apprenticeship methods. Systematic instruction enabled consistent competence across diverse populations, while democratic participation encouraged innovation that exceeded compliance achieved through hierarchical control or cultural conformity. International cooperation through Lend-Lease programs provided American fighters to Allied air forces while maintaining domestic production superiority that ensured continued technological leadership. Democratic values created sustainable partnerships that authoritarian systems couldn't replicate through coercive methods or temporary ideological alignment. The maintenance infrastructure supporting American fighter operations revealed systematic approaches to equipment lifecycle management that Japanese forces had never developed. Standardized spare parts, replacement procedures, and repair manuals enabled sustained operations at scales that Japanese tradition couldn't support through improvised maintenance methods or individual technical expertise. Storage facilities for surplus fighters demonstrated American confidence in continued production that exceeded immediate military requirements, treating strategic reserves as routine inventory management rather than desperate resource conservation that characterized Japanese military planning throughout the Pacific War. The statistical analysis conducted by Japanese intelligence services in September 1945 revealed production figures that rendered continued resistance mathematically impossible rather than merely strategically challenging. American fighter manufacturing had reached 96,000 units during the war years, while Japanese production peaked at 16,000 fighters across all models despite maximum industrial mobilization and resource allocation. Lieutenant Commander Sakai's combat reports provided tactical context for strategic statistics that demonstrated systematic American advantages beyond individual aircraft performance. Enemy fighter formations had grown progressively larger throughout the war, indicating replacement rates that exceeded Japanese ability to inflict sustainable casualties, despite tactical victories achieved through superior pilot training and combat experience. Technical superiority of American fighters reflected research and development programs that operated without resource constraints limiting Japanese innovation. Advanced electronics, sophisticated engines, and precision manufacturing indicated systematic advantages in industrial science that competitive markets had encouraged through democratic organization rather than centralized planning or ideological motivation. The pilot training disparity became apparent through intelligence analysis of American flight schools that graduated 5,000 fighter pilots monthly using systematic instruction methods, compared to Japanese programs that produced 800 pilots monthly through traditional apprenticeship approaches that required individual attention from experienced instructors who were increasingly unavailable due to combat casualties. Economic efficiency calculations revealed American fighter production costs that decreased as manufacturing volumes increased, achieving superior performance through industrial optimization rather than resource abundance alone. Democratic capitalism had proven more effective than command economy organization for systematic resource allocation that benefited both military effectiveness and industrial development. Maintenance capabilities observed through captured American facilities demonstrated systematic approaches to fighter serviceability that Japanese forces had never achieved, despite technical expertise and dedicated personnel. Standardized procedures, abundant spare parts, and systematic replacement schedules maintained operational readiness at rates exceeding 85%, compared to Japanese serviceability rates below 60%. Strategic reserves documented through reconnaissance revealed American confidence in continued global responsibilities that extended beyond military victory to peacetime international leadership through industrial capabilities. Fighter aircraft held in storage exceeded Japanese total production, while representing preparation for conflicts that might never occur rather than desperate conservation of precious resources. Innovation continuation beyond immediate military requirements included civilian applications of fighter technology that would dominate post-war aviation markets. American aeronautical engineering had created systematic advantages in aircraft design, manufacturing, and operation that would influence global transportation development for decades following military victory. International cooperation through fighter sharing programs had demonstrated American ability to support Allied air forces while maintaining technological superiority that ensured continued leadership. British, Soviet, Free French, and other forces had received American fighters that enhanced collective effectiveness while reducing American operational burdens through shared responsibility. The workforce development that enabled such success included systematic education programs that created human capital advantages through individual empowerment rather than collective sacrifice. Technical training, professional development, and social mobility had enhanced American manufacturing capability through democratic participation that authoritarian systems couldn't replicate. Quality standards maintained throughout mass production had exceeded Japanese peacetime manufacturing, despite wartime urgency and resource demands. Statistical quality control, systematic testing, and continuous improvement had achieved reliability that traditional craftsmanship methods had only accomplished through individual attention that mass production schedules couldn't accommodate. The mathematical certainty was overwhelming. American fighter production alone had exceeded total Japanese aircraft manufacturing across all types, while maintaining superior performance standards that rendered tactical resistance futile against systematic industrial advantages. October 1945. The comprehensive intelligence assessment, prepared by surviving Japanese aviation experts, documented American fighter production capabilities that had rendered continued resistance not just difficult, but mathematically impossible. The final statistics were overwhelming. Over 20,000 operational fighters sat ready at American airfields, with production capacity that could replace the entire Japanese Air Force within 6 weeks. The psychological transformation among Japanese military leadership reflected comprehensive reassessment of American industrial capabilities that extended beyond aircraft manufacturing to encompass systematic advantages in resource allocation, technological development, and workforce management that democratic organization had achieved through competitive methods rather than administrative control. Technical analysis conducted by captured Japanese engineers confirmed that American mass production had achieved quality standards that exceeded individual craftsmanship while producing quantities that traditional methods could never accomplish, regardless of available resources or workforce dedication. Democratic industrial organization had proven superior to authoritarian economic planning through systematic competitive advantages. Strategic implications extended far beyond military defeat to encompass fundamental questions about Japanese industrial philosophy and national economic development. American abundance had been achieved through technological innovation, systematic education, and democratic participation. The Japanese tradition had never attempted despite centuries of craftsmanship, excellence, and administrative efficiency. The economic lessons learned through intelligence analysis would influence Japanese post-war reconstruction toward democratic capitalism and international cooperation rather than autarkic military industrialization. American methods that combined research, development, and mass production had created sustainable advantages that competitive markets encouraged through individual initiative rather than collective sacrifice. Personnel development programs observed in American facilities included systematic training, educational opportunities, and social mobility that created human capital advantages through democratic values rather than hierarchical control. American society had proven more effective than Japanese tradition for developing technical competence across diverse populations while maintaining innovative capability. Innovation acceleration under mass production conditions had contradicted Japanese assumptions about the relationship between quantity and quality in advanced manufacturing. American engineers had achieved continuous improvement through competitive methods that central planning had never accomplished, despite ideological motivation or administrative efficiency that Japanese systems had emphasized. International cooperation through fighter sharing had demonstrated American ability to support global alliances while maintaining technological superiority that ensured continued leadership. Democratic values had created sustainable partnerships based on mutual benefit, rather than coercive relationships that authoritarian systems had attempted through military dominance or ideological conformity. The workforce diversity that contributed to American success challenged Japanese assumptions about social organization and technical capability. Women, minorities, and immigrant workers had enhanced, rather than compromised, manufacturing effectiveness through systematic inclusion that democratic society had enabled, despite traditional prejudices that other systems had institutionalized. Quality control achievements through statistical methods had exceeded individual craftsmanship standards, while enabling mass production that Japanese tradition considered impossible without compromising functional requirements. American standardization had solved fundamental manufacturing problems through systematic approaches that individual expertise had never adequately addressed. The preservation of surplus fighters demonstrated American preparation for post-war global responsibilities that assumed continued technological leadership through industrial capacity rather than military occupation. Strategic planning that maintained excess production indicated confidence in competitive advantages that would influence international relationships through economic development rather than military coercion. Personal accounts from Japanese pilots who had encountered American fighters throughout the Pacific War confirmed intelligence assessments about systematic advantages that had rendered tactical excellence mathematically irrelevant against industrial capacity that produced replacement aircraft faster than Japanese forces could destroy them. December 1945. As Japan began reconstruction under American occupation, former fighter ace Saburo Sakai visited American airfields that had once seemed impossible to believe. The reality exceeded even the most alarming intelligence estimates. Systematic rows of fighters stretched beyond visual limits, representing industrial achievement that redefined national power through productive capacity rather than military tradition. The final accounting revealed American fighter production statistics that had exceeded Japanese total aircraft manufacturing by factors that made resistance meaningless rather than merely difficult. Over 78,000 fighters had been produced during the war years, while Japan's combined output across all aircraft types reached only 76,000 units, despite 4 years of maximum industrial mobilization and resource sacrifice. Personal transformation among Japanese aviation personnel reflected comprehensive understanding of American advantages that extended beyond production numbers to encompass systematic approaches to technological development, workforce education, and economic organization that competitive democracy had achieved through individual empowerment rather than collective sacrifice. Technical superiority demonstrated through captured American aircraft revealed engineering capabilities that had operated without resource constraints limiting Japanese innovation. Advanced materials, sophisticated systems, and precision manufacturing indicated systematic advantages that market competition had encouraged through profit incentives rather than ideological motivation or administrative direction. Economic efficiency of American methods challenged Japanese assumptions about resource allocation and industrial development. Democratic capitalism had achieved superior performance while maintaining higher wages and better working conditions through systematic optimization that competitive markets had encouraged rather than administrative planning that command economies had attempted. The workforce development that enabled such achievement included educational programs that created human capital advantages through systematic instruction and democratic participation. Technical training, professional development, and social mobility had enhanced American capability through individual initiative that authoritarian systems couldn't replicate through collective ideology or hierarchical control. Innovation acceleration throughout mass production had contradicted Japanese beliefs about the incompatibility of creativity and systematic manufacturing. Competitive markets had encouraged continuous improvement through individual initiative while enabling mass production that achieved both quantity and quality through systematic methods that traditional approaches had never accomplished. International cooperation through technology sharing had demonstrated American confidence in continued leadership that extended beyond military victory to peacetime economic competition. Democratic values had created sustainable alliances based on mutual benefit rather than exploitative relationships that authoritarian systems had imposed through military dominance. Strategic planning, evident in surplus fighter production, had indicated American preparation for global responsibilities that assumed continued technological leadership through industrial capabilities that would define post-war international relationships. Excess capacity had represented confidence in competitive advantages rather than desperate resource conservation that scarcity-based planning had required. The preservation methods employed at storage facilities had demonstrated systematic approaches to asset management that Japanese military tradition had never developed. Climate control, maintenance schedules, and inventory procedures had maintained aircraft in operational condition, while treating strategic reserves as routine business practice rather than desperate emergency measures. Post-war analysis would reveal that American fighter reserves had exceeded immediate military requirements while establishing foundation for civilian aviation expansion that would dominate global markets through technological advantages developed for military applications, but adaptable to commercial use through systematic innovation. If this incredible story of how American industrial mathematics overwhelmed even the most experienced enemy pilots inspired you, make sure to subscribe to our channel for more amazing tales of how democratic abundance changed the mathematics of global power. The airfields lined with 20,000 fighters had represented more than military superiority. They had demonstrated systematic advantages that would reshape international relationships through productive capacity that made traditional concepts of national power obsolete in the industrial age.